There was a time when asteroid strikes posed a constant, all-too-real threat on our planet. Roughly 4 billion years ago, remnants of planet formation and so-called failed planets collided with the rocky worlds of the inner solar system, leaving impact craters up to 15 miles in diameter and about 10 miles deep. I'm your host Nathan, and you are watching Universe on a Stick. Don't forget to like and subscribe if you want to see more of these videos. The impacts continued to happen for a period of approximately 700 million years. However, the tail end of this period, which became known as the Late Heavy Bombardment, was marked by a sharp increase in impact events. Most researchers attribute this increased activity to the Jovian planets of the outer solar system, stating that the movement of these gas giants was what sent all that debris hurtling towards the rocky planets. Today, few craters remain on our planet due to its gradual but steady surface renewal. On the other hand, a fairly large number of such craters are still comparatively intact on the surfaces of Mercury and Venus, as well as Mars and even the Moon. Which makes you wonder if there was something about the asteroids that hit Earth in particular, something that made them different from the ones that slammed into the other rocky worlds. Now, there has been a lot of debate regarding how the Earth got all this water. The most favored theory is that Earth was in fact quite a dry place in the early stages of its formation, and that it received most of its water, if not all of it, from stray objects crashing into the planet during a period none other than the Late Heavy Bombardment. Today, asteroids are not exactly rich in water, but billions of years ago, things could have been so different than they are now. Asteroids could have had much more water. Whole lot of speculation there. How can we be certain about any of it? As I pointed out earlier, here on Earth, there isn't much left of the basins caused by these ancient impact events. Nevertheless, information about an asteroid strike can still be obtained by studying the rock layers at the site of the impact, even after the crater is long gone. The asteroid that wiped out the dinosaurs, which was roughly 6 miles in diameter, left a crater over 100 miles across and 12 miles deep. The Rutherford crater, left by an asteroid of the same name a little over 2 billion years ago, is estimated to have been 190 miles in diameter at the time. And yet, these two pale in comparison to the South Pole Aitken Basin, an impact structure on the Moon, which is over 1,500 miles in diameter. Could something like that have happened to Earth during the Late Heavy Bombardment? Let me know what you think in the comment section. Thanks for watching, and see you next time.